Okay, hi everybody. This is the May 2024 Extended Math MYP paper. Here we have question 1, so let's go. The following circle has center O. The points A, B, C, and D lie on the circumference such that O lies on AB. Given that the angle DAB is 44, determine the size of the following angles. So AOD, we want to know what this is here. Angle DOB, so DOB would be here, and then DCB here. Okay, so first things first, angle AOD, well, I know that this here is an isosceles triangle, which means this here would be 44 degrees also. If I subtract 44 plus 44 from 180, I would find that AOD is 92 degrees. So I'll fill that in. Angle DOB, I can therefore use angles on a straight line here. Must sum to 180, so 92 plus DOB would give me 180, so that has to be 88 degrees. And then angle DCB is going to be the same as here. Okay, so just 44 degrees again. Okay, for question 1b, we are asked to use your knowledge of circle theorems, write down why angle ADB is 90 degrees. Okay, so the explanation for this is that the angle at the circumference of a semicircle is a right angle because it is subtended by the diameter of the circle. And then I would relate to this specific diagram, and I would say that AB is the diameter, just to make it clear that you understand that. And then you want to make some sort of statement around, according to the circle theorem, an angle formed at the circumference by a semicircle will always measure 90 degrees because the diameter creates a triangle where the angle opposite the diameter is a right angle. Okay. But yeah, anything along those lines there. Okay, on to 1C. So given that AD is equal to 12 centimeters, BD is equal to 6 centimeters, find the length of AB. Give your answer in simplified third form. Okay, so this is Pythagoras. So 12 squared plus 6 squared is going to be equal to AB squared. So AB squared is 144 plus 36. AB squared is 180. Okay, and then you need to find, you need to square root both sides. So AB is equal to root 180. And then I would look for square numbers that would go into this. Now, if you're not sure where to start, okay, just pick a low square number. So if I pick root 4, I would need to multiply by 2. See, root 4, 45. Okay, so then currently what I would have would be 2 root 45, but 45 can be simplified further. So that's equal to 2 times root 9 times root 5. So then AB, if I simplify that further, I've got 2 times 3, which is 6, times root 5, so 6 root 5 as my final answer. Okay, and then hence determine the area of the circle. Give your answer in terms of pi. So if AB is the diameter, we know that the radius, so R, is going to be equal to 3 root 5. Now all I've done there is halved AB, okay? The area of a circle is pi r squared. So let's substitute that in. Okay, and that would be equal to pi times, let's think about this, so 9 times 5, which is equal to 45 pi, and units would be centimeters squared. Okay, on to question 2. So MYP Academy is presenting a talent show for their community. Some students from the academy and some members of the community are performing in the show. A total of 175 people will be at the show. In the following Venn diagram, set A represents the number of academy students at the show. Set B represents the number of performers in the show. And question 2A is wanting us to... So one person at the show is selected at random. Given that they are a performer, write down the probability they are an academy student. Okay, so given that they are a performer, okay, so the performers are set B. Okay, so I'm looking at these students here. So given that they are a performer, write down the probability that they are an academy student, okay? So the academy students within this set B are only these students here in the very center, okay? So I'm looking at 21 out of a total of 30. There's 30 people altogether in set B. So that's where that comes from. Okay, so 2B follows on from 2A in that 2 of the performers will be selected at random to introduce the show. Determine the probability that they are both academy students. So this follows on from 2A because we are still only looking at the performers, okay, and then the probability that they are academy students as well, okay? So we're going to pick 2 random students. So on the first pick, we could choose an academy student. The probability of that happening would be 21 out of 30. Okay, for the second pick, there would now be 1 less academy student and 1 less student overall. So our second pick would be 20 out of 29. Okay, and you just need to multiply these 2 together and simplify. Your calculator will do that for you, and you should be getting 14 out of 29. Okay, then on to 2C. We are going to show that A and B are not independent, so you are going to need to use your independent events formula here, which I've just put above us, above question 2C, but it is available in the formula booklet. Okay, so the probability of A intersection B should be equal to the probability of A multiplied by the probability of B if they are independent. So the probability of A intersection B, well, that's this central part here. So that's going to be 21 out of 175. Now that should be equal to the probability of A. So the probability of A altogether is 85 out of 175, and then the probability of B would be the total of B, so 30 over 175. So in terms of what you need to write to make sure you get the marks here, you just need to multiply these out, okay? So and show ultimately that they're not equal to each other, and that will give you the 2 marks for this question. But they have to see that you are making attempts to substitute into the formula. You can just add here that 21 over 175 is not equal to the result of this, so 2, 5, 5, 0 over 30625. Okay, they're clearly not equal to each other. Therefore, A and B are not independent. Okay, so on to question 3. We want the height of a lamp is calculated using a measuring instrument called a theodolite. The theodolite measures angles. The theodolite has a height of 1.6 meters. It measures the angle of elevation at the top of the lamp at 14 degrees to the nearest degree, and then it is moved 5 meters towards the lamp and measures the angle of elevation of the top of the lamp at 23 degrees to the nearest degree. The measurements are shown on the following diagram. Okay, so at this point, I would just think about what else do I know? Okay, I know that this is a horizontal line here. I know it's going to form a right angle here. If this is 23 degrees, then this here must be 157 degrees. And then I also know that this here must therefore be 9 degrees. Okay, so ultimately we're trying to find P. But currently I need a little bit more information from that left-hand triangle to work this out. So what I'm going to do is this here is what I want to find. So the hypotenuse of the smaller right angle, I shouldn't say smaller actually, the hypotenuse of the right angle triangle is what I need. And because I know all of the angles in the non-right angle triangle plus one of the sides, I'm going to use the sine rule to calculate this missing length. Okay, so I'll call this L for now. So we have L over sine 14. Okay, and that would be equal to 5, which is the other side that I know of this triangle, over the sine of 9. Okay, I'm going to solve this to find L. So L is going to be equal 5 over sine 9 multiplied by sine 14. Okay, that gives me L as 7.7323. So L is equal to 7.73 meters. Okay, now I've got that. If I think about this right angle triangle, I'll just draw it here so we know what we're talking about. Okay, I've got 7.73. I know that this here is 23 degrees. And what I want to find now is the height of this triangle. Okay, so this is going to switch now to right angle trigonometry. So I've got the opposite and I've got the hypotenuse. So sine 23 is equal to opposite over 7.73. Now I would keep the full decimal in at this point just to keep the accuracy of my answer. Okay, so what you should find at this point is you should get the opposite is equal to 3.0086. Okay, and that again is meters. So if I just go back to my diagram, what I have now is this part of the lamppost. Okay, but I have to remember I want the total height of it. So I also need to add on the 1.6. Okay, so we're going to take this 3.0086. We're going to add 1.6. Oops. And we would get an answer of 4.6086, which of course is 4.6 meters to 1 decimal place. Okay, so for question 4a, we are given that f of x is equal to 4x plus 1 and g of x is equal to 1 minus 3x over x minus 2. Solve f of x is equal to g of x. Okay, so all you need to do at this point is equate the two. So we have 4x plus 1 is equal to 1 minus 3x over x minus 2. I'm going to multiply both sides by x minus 2. So 4x plus 1, x minus 2 is equal to 1 minus 3x. Okay, at this point, I would want to expand and simplify. So 4x squared, we're going to have minus 8x, and then plus x minus 2 is equal to 1 minus 3x. Let's get everything onto the same side and simplify. So you can do that in a couple of steps if required. Or you can just go straight to it if you feel confident, that's fine. And then you are going to set this equal to 0. So what you have now is a quadratic that you are required to solve to find the 2x solutions. You've got two different options. You could use the quadratic formula. You could also factorize for this one, whichever you feel most confident doing. For myself, I think personally I naturally just go to factorizing. So to factorize this, if you want to use the method, you'd be using the AC and B method. So A times C is negative 12, and then B is minus 4. So in order to achieve negative 12, you could have negative 1 times 12. You could have 1 times negative 12. You could have negative 2 times 6, or you could have 2 times negative 6. You could have negative 3 times 4, or 3 times negative 4. So one of these needs to add to give you negative 4. Now I can see that it's only this one that would do so. 2 plus negative 6 would give me negative 4. So then I go back to my quadratic, and I'm going to rewrite it as plus 2x minus 6x minus 3 equals 0. And I'm going to factor as two single brackets. So the first one, highest common factor is 2x. Then in the bracket, I would have 2x plus 1. Then I would subtract, highest common factor is 3. So then inside of the bracket, I would need 2x plus 1 again. Now, as long as those brackets are the same, you've done this correctly. So to actually get your final answer, you take what's outside of the bracket and form a bracket, and then you only require one of the repeated brackets. Okay, you don't need to write it twice. So there's my factored form. Now to solve this, I just need to set each bracket equal to 0 and find the solution. So okay, so we have either 2x is equal to 3, which means x is equal to 3 over 2, or we have 2x is equal to negative 1, which would mean that x is negative 1 over 2. Okay, so just to highlight the two answers, there we go, our 2x solutions. Okay, on to part B. So it says, using your answers from A, find the values of the y coordinates of point A and point B. So what we need, so we need our 2x solutions, so 3 over 2, and x is equal to negative 1/2, and you need to take one of the functions, okay? So if we take f of x, so f of x is equal to 4x plus 1, and all I'm going to do is substitute these x values in to find the corresponding y values, which would be our y coordinates, okay? So we have f of 3 over 2. So 4 times 3 is 12. 12 over 2 is 6, plus 1 is 7. Okay, so my coordinate for for B, because I did B first, because why not? So B is going to be 3 over 2, 7. And then you would repeat the process for A. Okay, so you just need to substitute in your other x value, so f of negative 1/2 would be equal to 4 lots of minus a half plus 1. So f of minus a half is going to be equal to negative 2 plus 1, which is minus 1. So then our coordinate for A would be minus a half minus 1. You can, of course, look at the coordinates on the graph to see if this looks logical, if it makes sense. Does it look right? Which here it does. Okay, for question 5, a ball is dropped from a height of 500 centimeters and bounces on the ground. In between each bounce, the ball follows a parabolic path. The height that the ball reaches decreases after each bounce. The heights are indicated on the diagram in centimeters. So for question 5a, the heights form a sequence with first term 500. Show that the sequence is geometric with common ratio r, where r is equal to 0.8. So the common ratio can be found by dividing two consecutive terms. So to show that r is equal to 0.8, you need to do so. So 400 divided by 500 is equal to 0.8. Now it's not enough to do it just for one pair of terms, okay? So you need to pick another. So 320 divided by 400 also would give you 0.8. In the same way, if you did 256 over 320, it would also be equal to 0.8. But they are looking for two examples to be able to obtain the mark, okay? So then we want to determine the value of the 10th term. So we know this is a geometric sequence, okay? So U10 would be equal to the first term, so 500, multiplied by the common ratio, which is 0.8, to the power of 10 subtract 1, okay? And then this just needs to go into your calculator, and you should find that U10 is equal to 67.1, and this is centimeters, I think. Yes, centimeters. Okay, so the ball keeps bouncing towards a target. The diagram below illustrates the final parabola. Find the equation of the parabola in the form h of x is equal to a x minus b all squared plus c. So first thing to do, this is vertex form, okay? So you need to substitute in your vertex. So we're going to have minus 690 all squared plus 27.5, okay? What you then need to do to find your a value, okay, is substitute in another point. So I'm going to use this point here. So 0 is equal to a lots of 680 minus 690 all squared plus 27.5. So I have 0 is equal to a lots of negative 10 all squared plus 27.5. So 0 is equal to 100a plus 27.5. If I rearrange, we have 100a is equal to negative 27.5. I'm going to divide by 100. So a is equal to negative 0.275. Okay, and what you need to do here, just to get that final mark, is substitute that back in. So just make sure you've written clearly that h of x is equal to negative 0.275, open brackets, x minus 690 all squared plus 27.5. Okay, let me just move that bit up here so it can be seen a bit better, and then that would be your final answer here. Okay, on to question 5D. The ball hits the target at the coordinates L 17.6. Find the value of L. So you are going to use the equation that you've just found and set that equal to 17.6. So 17.6 is equal to negative 0.275 bracket L minus 690 all squared plus 27.5. And then this is just a process of rearranging, okay? So you would subtract the 27.5 from both sides. First of all, what would that give you? That would give you negative 9.9 maybe? Gosh, my brain's not working right now. Let's see. Okay, let's try that again. Yeah, negative 9.9, I was right, equals negative 0.215 brackets L minus 690 all squared. Okay, so then you would divide both sides by minus 0.275. Oh, 215. Why did I write 215? It's 275, isn't that silly? Okay, do the same on the other side. Okay, at this point, we would be getting minus 275. 36 is equal to L minus 690 all squared. So square root both sides, so 6 is equal to L minus 690. Add 690 to both sides. We would have that L is equal to 696. And there we have it finally. Okay, on to question 6. So, around the time of the French Revolution in 1790, French scientists created the metric system to measure weights and distances. For a few years, the French abandoned the Gregorian 24-hour measure of time and adopted a metric measure of time. This metric time was called the French Revolutionary Time and began officially on the 24th of November 1793. Humans have evolved to live within the routine of a day. Metric time used 10 hours for one day instead of 24 hours for one day. Each metric hour has 100 minutes and each metric minute has 100 seconds. Despite its simplicity, the new system was not at all popular. Replacing all clocks was expensive and it became increasingly difficult to trade with other countries which did not adopt the metric time. In this question, you will make comparisons between Gregorian and metric time and observe how simple calculations are in terms of metric time. So 6a, the following diagram shows one day in two systems of time, metric and Gregorian. Write down the missing times on the diagram. So the best thing to do here is look at the scales, okay? So we are going from 0 to 5, and the first box to fill in is halfway. Okay, so this would be 0 to 50. Now, it's 50 because this is metric time, so it goes up to 100, so halfway would be 50. Okay, you are then going to repeat the following side, so 0, 750. Okay, and then if we look at the bottom, so for III, so this is the Gregorian 24-hour day, we can see that this is halfway, so we know that halfway is 12 p.m., so you just need to fill that in. So that's 6a done. So then question 6b, determine the number of Gregorian hours and minutes in 1 metric hour. So really you needed to use this diagram. The best thing that I would do, so the way I would do this is I would focus on a distance that I know for both, okay? So if I think of the Gregorian 24-hour day, so from midnight until 6 a.m., that's 6 hours. Okay, so Gregorian, so 6 hours is equal to 2.5 hours. So 2.5 hours for the metric time. Okay, we are wanting to find what 1 metric hour is equivalent to, okay, in hours and minutes. So what I'm going to do, because I want my metric to be 1 hour, I know that I need to divide here by 2.5. Okay, so I'm going to do the same on the other side and divide by 2.5. Okay, so just grab your calculator at this point, and all you need to do is 6 divided by 2.5. You would get 2.4 hours. Okay, so your 2 hours is known, you can fill that in, but what you do need to know is, well, what is 0.4 of an hour in minutes? Okay, now for the Gregorian system, there's 60 minutes in 1 hour, of course, so you need to do 0.4 multiplied by 60 to find your minutes. Okay, you would find this to be 24 minutes. Okay, so then we are on to metric time conversions as shown in the following infographic. So we have stage 1. So 1 minute is equal to 100 seconds. We are also told that 528,030 metric seconds is equivalent to 5 days, 2 hours, 80 minutes, and 30 seconds. Okay, so we are given the below times. So the first one is 90 minutes. Okay, so I know from my stage control above, 1 minute is 100 seconds. Okay, so I need to multiply 90 by 100, okay, which would give me 9,000. Okay, so then I want to write this in standard form. So my first number needs to be between 1 and 9.999, okay, less than 10. And I am multiplying by 10 to the power of 3 to give me 9,000. Okay, for the next one, 2 hours and 40 minutes. Now this would be the same as 24,000 seconds in metric time. Okay, so your first number for the standard form would be 2.4. Okay, and then you are going to multiply by 10 to the power of 4 this time to get that number. Okay, and then, should have done this further down. Let me just repeat that. So we've got 9 times 10 to the power of 3. We've got 2.4 times 10 to the power of 4. Okay, for this next one, we're being told that it's 5.3 times 10 to the power of 3. Now, you really want to, well, I should say it kind of helped if you got this first one right here, okay? Because you could use that to help you, because I would recognize, well, 10 to the power of 3, that's the same. Well, if that's how I notate 90 minutes, well, then I know that this one must be 53 minutes. Okay, and then on to the last one, 4 days, 2 hours, and 5 minutes. Well, your 4 days this is just slightly bigger than what we've already done here. Okay, so instead of it being starting with the hours, we're going to start with the days. So 4.205, and we're going to need to multiply that by 10 to the power of 5. It's one more place because it's days rather than just hours and minutes. On to question 60. All the following questions are in the context of metric time. So we are given various inequalities shown on an axis, okay? So S represents the number of single lessons, D represents the number of double lessons. So instead of X and Y, we have S and D, and we have various different stages to this. So here we have the region S is greater than or equal to 10. We have this region here as part of stage 2. This is part of stage 3. And then this is part of stage 4. So we are asked to determine the missing elements in the following table and describe the region in words, okay? So for this inequality here, this is the number of single lessons is greater than or equal to 10, okay? So the number of single lessons is greater than or equal to 10. For the next bit, you need to find the inequality that goes with this, so the one that's just about D. So if I go back through my stages, okay, I can see here, so on my D axis, I have 5 and my region is below 5. You can see also that it's a solid line here, so that means anything in my region up to and including this line. Okay, so when I write this as my inequality, D has to be less than or equal to 5. So the number of double lessons is less than or equal to 5. You could also put at most 5. The next one, so S plus D is something to do with 16. So let's find the stage that goes with that. Well, I can see here, this is the stage that goes with that. And I want above this, okay? And can you see also that this is a dashed line, okay? So this region can equal anything above this, but not include the line, okay? So S plus D needs to be greater than 16, but not equal to. So the total number of single and double lessons is greater than 16 or more than 16. Greater than 16. And then for the last one, if we look at the last region, I can see the region is below a dashed line, okay? So when I go to this last inequality, I know that this has to be less than 92. It can't be equal to because it's a dashed line, okay? So on to question 6E. So we are asked to, the diagram below shows all constraints in one graph. The mathematics department wants to allocate lessons within the constraints given above. Find the values of S and D that will give the maximum number of minutes. Okay, so what I'm actually going to do here is basically color all the regions that it can be, and then decide where I have all of my colors, okay? So I'll do this with different colors so that hopefully it's nice and clear. So that's the first region. I then had this region that it could be equal to. Then I had the region above 16, so this here. Okay, and then I also had the region below here. Okay, so this looks kind of crazy at this point. What you need to do is decide where you've got all of the different colors. Okay, so let me just get rid of the regions that I know it can't be. So it definitely can't be this bit. It's not this bit or this bit because that definitely doesn't have all of them. Let me zoom in carefully here. And I can see that it's this triangle, this small triangle section. Okay, so if I just highlight that, we're looking at this bit here, but let's remember that those lines are dashed, okay? So it can't actually be equal to the line itself. So I'm just looking within this region here, okay? So I know what section is included. So now let's go to the question. So we want to find the values of S and D that will give the maximum number of minutes. Okay, so I know that it has to be something within something within this section. Now, of course, we have to have whole numbers, don't we? So in terms of what I could have, okay, I could have 16.1 is a point, okay. I also have 15.2 just inside the region, but then I cannot see any others that would satisfy these inequalities except for 17.0, but I want to have lessons from both, okay? So either we have 16 singles and 1 double, or we have 15, not 17, 15 singles and 2 doubles, okay? So once I've got to that, I just need to calculate what this would actually work out as, okay? So what? Okay, so in terms of how long the lessons are, we have 20 for a single and it's 40 for a double. Okay, so let's look at the first one. We're going to have 16 times 20 and then we're going to add 40. That gives me a total of 360. Okay, for the second one, I would have 15 multiplied by 20, and then I would need to add 80. So 15 times 20 is 300 plus 80 is 380. So I can see here that the 15 singles and 2 doubles actually gives me the maximum number of minutes. So you just want to say 15 singles, 2 doubles. You can notate that also as S equals 15 and D equals 2. Okay, for question 6F, we need to show that the rate of production is 2.987 milligrams per minute. Okay, so we've been told that it takes 1 metric day for the solution to form 2.987 grams. Okay, so in 1 metric day, there is 1,000 metric minutes. So the first thing I'm going to do is divide by 1,000. Okay, so 2.987 over 1,000, that's going to give me the rate per minute. So 0.002987, and that's grams per minute. Okay, now obviously we want milligrams. So knowing that there are 1,000 milligrams in a gram, you then need to multiply by 1,000. Okay, so 0.002987 multiplied by 1,000, and you would get 2.987 milligrams per minute. So you just get back to the same number that you started with, but the rate has changed. Okay, so then on to question 6G. So calculate the maximum number of grams that can be produced from 4 o'clock on day 1 to 490 on day 2. Give your answer to the nearest gram. Okay, so you need to recognize here that this works out as 1.09 days in metric time. So then you're just going to multiply your day amount, so 2.987 grams multiplied by 1.09. Okay, and then this would give us 3.25583. Now just note the last part of this question. It does ask us to answer to the nearest gram, so you do need to round. So the closest gram would be 3 grams for this question. Okay, moving on to question 17. Okay, for question 7a, we have the relationship between life expectancy and other factors is represented on the following scatter graphs. Identify the correlation for each of the scatter graphs. So the first one would be none. Okay, I cannot see any general trends there. The second one is definitely negative. I need to decide between strong negative or just negative. If I look at the one to the right of it, I can see that is a stronger trend. So this would be negative, and then this would be my strong negative. Okay, and then on to the last two, similar sort of thought train. So I have strong positive as the last one, and then just positive for this one here. Okay, so there are 11 countries positioned on the Tropic of Capricorn, sorry. The life expectancies in 2021 for these 11 countries are as follows. Okay, so write down the missing values in the box and whisker plot. So you need to find, you know that this is the lower bound. Okay, so we know that 85 would be the upper bound. So I can pop that straight in. So then I need to find my median. So I'm just going to cross them off until I find the middle. Okay, so I can see that there's 71 in the middle with a total of 5 values either side. So there is a specific value that falls in the middle. I'm going to repeat the process for the lower quartile and the same for the upper quartile. Okay, so you can see that we're left with 61 as the lower quartile and 79 as the upper quartile. Then for my mode, I am looking for the most common value. From my list of numbers, I can see that only 59 is repeated more than once. So 59 would be my mode. Okay. So then on to question 7c. It is asking us, so hence determine the following measures of dispersion. So first of all is the range. So I find the range by subtracting the smallest value from the biggest value. So 85 subtract 59, and I should be getting 26. Okay, for the interquartile range, so let me just come down here a little bit. We should be subtracting the upper quartile, so 79, subtract 61, which is the lower quartile, to find that interquartile range. So that would be just 18. Okay, and then we are on to 7d. So the news headline, the life expectancy on the Tropic of Capricorn is higher than the life expectancy on the Tropic of Cancer. Okay, for question 7d, a slightly more challenging question for me to go through with you. So what I will do is basically explain where the marks on this question are coming from. Okay, so do always use the question to help guide you. Okay, read everything really carefully. So for the first box here, it's asking you to identify the elements relevant to your comparison. Okay, so within the mark scheme, you had to identify 3 from either the mean, mode, or median. From the range or the interquartile range, or the trend over the years. Years. Or the best line of best bet. Okay. So then what we needed to do was compare the measures. Okay, so using the elements that you have just identified, you needed to compare them. Okay, so include values of each and draw comparisons. Okay, so that could mean things like the mode of this is lower than the other, or the mean of the Tropic of Capricorn is higher than the mean of the other. But you had to make clear comparisons using values. Okay, had to include values. Okay, so in terms of the way the mark scheme works here, okay, so for the 4 marks in this specific part, you had to see values from the mean, and 1 from the range or the interquartile range, and 1 from the mode or the median. Okay, if they were not seen, you could not access that 4 marks. So then after that part, you need to comment on the headline. Okay, so you need to refer from all the things you've just talked about and link back to the headline. Okay, so what is the headline saying? Do you agree with it? Does your data show that you should agree with it? Does it, cast any doubt? What is your comment on the headline having looked at the data? Okay, so link back to the headline. So for C3, which was the highest mark for this part, okay, it says correct comment on the headline referring to trend over the years with specific years. Okay, so you not only had to link back to the headline, but you needed to include specific years. Okay, and what I mean by that is, so you could deem the headline to be correct up to 1980, 2000, okay, and then you could say that it's incorrect after this time. Okay, you could say that after 1950 Capricorn was higher for 30 years, but then in the last 20 years it's switched or it's changed. You could say that there was a gap, but it narrowed in 1980. There was a gap for 30, 50 years. All those sort of things where you're being very, very specific on the years that you agree with the headline and then the years that you do not agree with the headline. Okay, and then for the last part, which was the justification, so justify the degree of accuracy of your results. Okay, so you needed to include at least 2 reasons. So 2 reasons that imply accurate or inaccurate results. Okay, and those reasons could be things like it's inaccurate as image 1 does not indicate which average is graphed. Okay, it could be inaccurate as life expectancies were rounded. It could be inaccurate as Capricorn only has 11 countries and the tropics don't have the same. Or you could say that it is accurate as the data given in the graph starts from 1950. So you've had a long period of data. You could say that it's accurate as you compared both measures of central tendency and measures of dispersion. But either way, so whether you are saying that it's accurate or inaccurate, you need to state 2 of the reasons, okay, to get your 2 marks for that question and finish with full marks. Okay, we are on to the final question, which is question 8, our 30-mark question. This is, of course, going to be our investigation. So 8A, we need to show that the gradient of the diagonal line in stage 4 is -5/4. So I'm just going to pull out both coordinates for this and substitute into the gradient formula. So I have 0, 5, and I have 4, 0. So changing y over changing x, so 0 subtract 5 over 4 minus 0 would be equal to -5/4. And that's all you need to do for that question. Okay, on to 8b. So write down the missing values in the table up to row 6. So you just needed to continue on the pattern. So 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, 7. So then here we would have -6/5 and then -7/6. Okay, that again would give you your 2 marks for that question. Okay, describe in words 2 patterns in the table for the gradient. So 2 patterns, okay? Here it's quite nice because you've got a numerator and a denominator. Okay, so you can just say numerator decreases by 1. By 1. And the denominator increases by 1. Okay. What else could we say? That's it, really. Okay. Right, for 8D, write down a general rule for G in terms of N. So G in terms of N, let's just come back to our table here. So I'm just going to think about my numerators as a sequence first of all, just to help me. So I have -2, -3, -4, -5, -6 onwards. Okay, so what's happening here is we are subtracting 1 each time. So that means -n. Okay, now if I had just -n, my sequence would be -1, -2, and so on. So I need to subtract a further -1. Okay, and then if I think about the denominator, well, that is just my n value. Okay, so I would end up with -n minus 1 over n. Okay, so you can simplify this and rewrite it in different ways. Okay, so you could, if you wanted to, take out the negative and have n plus 1 over n. Like, it's the same thing. So either of those seen would get you the mark. Okay, so then verify your general rule for G. Okay, so for verification, you need to use the n values for which you have predicted. Okay, so n values that you have made predictions for. Okay, so if I go back to my table, that's going to be for 5 and 6. Okay, so we have to use n is greater than or equal to 5. So let me just get my rule. So g of n. So g is equal to -n minus 1 over n. Okay, so we're just going to substitute n. So g of 5 is going to be -5 minus 1 over 5, which is equal to -6 over 5. And now you just need to say this matches my prediction. And then you could repeat the process for 6 as well. So minus 6 minus 1 over 6, which is negative 7 over 5. This also matches my prediction. Then you can put something like hence verified. Okay, so then on to 8F, the final question. You will now consider the length of the diagonal lines. Okay, so you're given another table, so you are going to have to repeat all of the same processes that you've just done in the earlier part of the question. Like the earlier part of the question always guides you through this. Okay, so the first thing to do is complete your table, of course. So 5, 6, 6, 7, and then for your final column, you might like this might not be as clear, so just play around with it in the sense of think about what's happening. So if I'm going from 5 to 8, well 5 to 13, I'm adding 8. Here is add 12. Here is we're adding 16. So I can already see, okay, well, that's plus 4, plus 4. So if I plus 4 again, I should be adding 20. Okay, so root 61. And then if I add 4 again, I need to add 24. So that would be root 85. Okay, so just think carefully about what patterns are happening. What can I see that's going on? Okay, so then we have our big investigation. So investigate the values in the table to find a relationship for the diagonal length in terms of n. In your answer, you should communicate the following in an organized and coherent manner. So predict more values and record these in the table. We've done that, okay, so I can tick that off. So the first thing that I need to include here is describe in words a pattern in the table for the diagonal length L. So I need to look carefully in terms of my pattern. Now, what I've already done in terms of when I was completing this table is I've been able to identify that this is a quadratic sequence because my second difference is constant. Okay, so because it's plus 4, I know that this sequence, if I'm just looking at the numbers underneath the square root first, is going to be something to do with 2n squared. Okay, so in terms of describing in words a pattern, okay, you need to say that this is a quadratic sequence. Okay, so the pattern follows a quadratic sequence. Okay, and then let's see, describing what, yeah, that would do for this one in particular because it doesn't say 2, just says describing words a pattern. So it is a quadratic sequence, so that's fine. Now we do need to find a general rule for L in terms of n. Okay, so I know that it starts with 2n squared, so I'm just going to write my values down here. So what is, I've got 5, 13, 25. Okay, so 5, 13, 25, 41, 61, and 85. Okay, so I know that it's 2n squared, okay, because my my second difference, was 4. Okay, so what I'm going to do here is I'm actually going to write out the sequence for 2n squared underneath. So remember that the position is my n value. Okay, so for the first one, 2n squared would be 2. The next one, 2n squared would be 8. Then I would have 3n squared, so 18. 16, 32, 50, and square 36, 72. Okay, so just if that is unclear what I've done there, all I've done is substituted these values into this to give me this second sequence. Okay, now what I'm going to do is I'm going to compare. Okay, so I can see here, okay, I need to subtract 3. Sorry, not subtract. What am I doing? I need to add 3. Okay, then I need to add 5. Then I need to add 7. Then I need to add 9. Then I need to add 11. Okay, so again, okay, I'm going to take this difference as a new sequence to find the rest of my quadratic. Okay, there is different ways to do this. This is just the way that I learned. Okay, so you may have a different way to do this. That's absolutely fine. If you use the ABC values, fine. Okay, you just keep doing that. So then I've got 3, 5, 7, 9, 11, 13. So I'm going up by 2 each time, adding 2. So I know my sequence is plus 2n. And then I need to add a further 1 to get to 3. So plus 2n plus 1. So I know that the general term is this. However, I must not forget my square root. Okay, so the square root is 2n squared plus 2n plus 1. And that's my rule for L. So L is equal to the square root of 2n squared plus 2n plus 1. Okay, so then what you need to do, have I got some more space? Yep. In fact, let me just come down onto this next page. Should be a bit more easy. Oh. A bit more easy. That was terrible English, wasn't it? Okay, never mind. Okay, and then okay, so we've got our rule. Now we need to test and verify. So for testing, you want to make this really clear in your notation what you are doing. You need to use the values in the table that were given to you. Okay, so do not use your predicted values. Just use the values given to you. So if I go back to the table, that is anything from 1 to 4. Okay, so n has to be less than or equal to 4. So if we do L of 1, that would be the square root of 2 lots of 1 squared plus 2 lots of 1 plus 1. So L of 1 is equal to the square root of, so 2 plus 2 plus 1, which would give us root 5. Again, you want to go back to your table. Yep, this is correct. Okay, so this matches table. You want to repeat this process. So L of 2. Okay, so 2 lots of 2 squared plus 2 lots of 2 plus 1. So L of 2 is equal to the square root of 8, 12, 13. Okay, this matches the table. So at this point, you can say something like testing complete. Okay, and then you want to go on to verify. So I'm just checking that it's only 2. Yeah. Yeah, so you must recognize that you've calculated the right value, okay? So these little sentences are really important, okay? So that's your testing done, okay? So now we're going to verify. So for your verification, verify, we're going to use n values less than or equal to 5. So L of 5, that would be equal to the square root of 2 lots of 5 squared plus 2 lots of 5 plus 1. Okay, so L of 5 is going to be equal to, let's see, so 5 squared, 25, 50, 60, 61. Okay, again, this matches the prediction, You're going to repeat for 6. So 2 lots of 6 squared plus 2 lots of 6 plus 1. Okay, so L of 6 is equal to the square root of, so 36 times 2 is 72, plus 12, 84, 85. Okay, and again, this matches the prediction. Hence, my rule is verified. Okay, so that's this part done. Now we're on to justify. Okay, so I always say this to my students, but this is the hardest part always. Okay, and to be honest with you, if you can get up to this part and you've done everything else correctly and then you get no marks for the justification, you should still be able to get at least 15 of the marks. Okay, so try your best to get to this. And then just have a go, because even if you're just attempting to justify, you will still pick up marks for this. Okay, so let's have a look. So you just need to think really about what is it that you've actually done in this investigation. Okay, so you've been calculating the length of these diagonal lines. Okay, so if I go to my table, we're given a base, we're given the height, and we've got the diagonal length. Okay, well, when we find the hypotenuse of a right angled triangle, we would use Pythagoras, right? So A, B, C. So we'd have A squared plus B squared equals C squared. So then C would be equal to the square root of A squared plus B squared, correct? Where A is equal to the base, B is equal to the height, or vice versa, whichever, they are interchangeable. Okay, so realistically, that's all that we're doing here. So I'm going to just write out the sequence for the base that I had in my table. So the base was 1, 2, 3, 4, 5, 6. Okay, so 1, 2, 3, 4, 5, 6. The height was equal to 2, 3, 4, 5, 6, 7. Okay, so 2, 3, 4, 5, 6, 7. Okay, so what did we really do? Okay, well, let's find a sequence for each of these in terms of n. Okay, so for the base, in terms of n, it is just n. So b is equal to n because it just goes up by 1 each time. Now for the height would be equal. This is slightly different. Now it is adding 1 each time, so it would be n, but we need to plus 1 also. Okay, so then if I think about applying Pythagoras with this algebra, okay, so go back to this. A is my base. Okay, so base squared, so n squared plus, we're going to have n plus 1 all squared, and then we're going to need to square root this, okay, to give me my diagonal, which diagonal distance. Okay, so then if you multiply this out, we would have the square root of n squared plus, so this would be a double bracket, wouldn't it? Okay, so again, just expand and simplify. So we've got n squared plus n squared plus n plus n plus 1. Okay, and that's all going to simplify to 2n squared plus 2n plus 1, which is identical to L. So in terms of getting to this point, you just want to say something again, saying, hence my rule is justified. And then, yeah, that's it really. So all you've done, hence my rule is justified. You could explain like you've applied Pythagorean theorem, but you don't need to do that, okay? You would get the full marks for this being seen, okay? So that is the paper complete, and that is again just May 2024 Math Extended MYP assessment.